I don't want.
The late. Oh my God. All right. Hello. So, let me do this. Let's start off with any questions anybody might have from homework or anything, and then once more people come in, I want to show you a couple things I've added on Canvas. Anybody have any questions from homework or general questions or any?
I have a question about the quiz. We have a quiz on Monday. How it's gonna be on Zoom or like how?
Whoa. I promise I will have it figured out. I'm almost certain I'm going to do it in class on Zoom, because otherwise I just want to maintain the integrity of things. So I will have a definitive answer. And if I do it that way, then it's going to be a part of class time. I can't have you on Zoom with the required something outside of class time. That makes sense, because then I might be running into somebody else's class. So if I do it in class, it'll be at the end of class, and I'll give you a certain amount of time to do it. That's more than likely the way I'm going to do it.
All right, sounds good. Thank you.
Cool. All right, I like that reaction. Anybody else? Question?
Yes, Asher.
Yes.
Yeah, for the homework, we have to do all 70 questions on the book.
I love it. Let me show you.
11.
You're a beautiful segue. It's almost like I planted you. So if you look at the homework sheet right here, if you can see my canvas, right?
Yeah, for sure.
It'll tell you exactly what to do. So 2 through 70 even.
Okay.
2, 4, 6, 8. Who do you appreciate? Nah, Jeff. All right, I understand.
Thank you.
And then chapter 2 is the 2 through 60 even. What's E30 mean? Well, I tell you right afterwards. Every third one, right? Not every third odd. Don't get too excited. Every third one. So you just have to be able to count by threes. So let me show you a couple other things. I've added an announcement about calculator workshops. So if you're interested, I will give, you got to love how cryptic I am, some extra credit for attending, but mainly you should attend in case you're not as familiar with the graphing calculator. Somebody was asking, they currently cannot, it's difficult to get a graphing calculator. Could they still attend? And I need to ask, that's a very good question, because this workshop needs to be able to handle maybe some calculator emulator apps. Anybody have any calculator emulator apps?
Yeah.
Like on my phone, I've got a TI-83 emulator app that is illegal nowadays.
It's free or I have to pay for that?
I don't know. You've got to look it up. Depending on what kind of phone you've got. You got Android, you got iPhone. There's a ton of them out there. All kinds of emulators. Some of them free. Some of them you got to pay for. I'm not going to be the arbiter of that. But I will tell you this. You cannot use your phone on quizzes or tests. So you might want to have another calculator besides that. So does everybody see that? That's up here. If you are interested in this at all, you can bring your questions and they'll go over some basics and they can ask questions at the end. What else did I want to show you?
I have a question about that.
Sure.
So isn't that during our class time, 5:30 to 7, and those are 6 p.m. to whatever?
I didn't even look at the time, to be honest. Oh yeah, 4 to 6 Wednesday, which you could leave at 5:30 to come to class. And then 6 to 8 Tuesday, that kind of sucks. I didn't even, to be really honest, I didn't even look at the times. They just now sent this out, so I'm not sure why they picked those times. Normally, they're pretty good about having an evening time and a morning time. But obviously, that didn't happen here for some reason. Sorry, buddy.
No worries. Just making sure that
Yeah,
you
you're
weren't
right.
telling us not to come to class and to go to this
Oh, I'm
instead.
sorry. I didn't even, like I said, I didn't even look. I just assumed that one of them would not overlap in class, and actually they both overlap with our class, which I am not appreciating. There's too many things to keep track of. But I'll reach out to them. Maybe they could add a third one. Okay. So the other thing I wanted to show was if you click grades. Oh, I just lost somebody. Damn. If you click grades and you click on an assignment you've turned in that's got a grade, I want to make sure everybody knows how to see my notes. If you click view, don't click this. That'll download what you uploaded. Click the view feedback, and then you can see the notes. I write notes here for you with question marks and X's and stuff, right? I mean, just in case there's anybody out there that didn't know that's how you did it. There you go. The Wabbit emu is a good one. Does everybody see in the chat, Charles? That was the one I was going to use right before I found the one I currently use. I downloaded the file. TI sued and had it removed, but I actually have the file, and I used to have it up on the website, and then they screwed the website up, and now I've got to figure out where the hell I put the file. It's somewhere here, and if I find it, I'm going to post it in Canvas for you. But I have the TI-83 calculator on my phone, basically, for free. But Wabbit emu is a good one, and it's just fun to say. Yo, wascooey wabbit. All right. Is everybody cool with this here? I had people resubmitting things not even knowing what was wrong because they didn't know how to see what I had written on their work. So that's not a good loop to get stuck in. Okay. I think that's all I wanted to show you here. Yes. That's plenty. All right. Let me stop sharing. Boop. Nifty. Let me do this. Pop. All right. So no other questions from homework or anything? I'm hoping.
I have one question.
Oh, go ahead.
Okay, so I know like you give notes when we turn in stuff like on what we messed up on and stuff like that. If we turn in corrections, will you like write anything to say like those are correct, or will you just mark it as complete?
Oh, wait. Do it. Oh, when you turn in corrections, I will, and after I look at them, I'll either say, okay, and change the grade to complete, or it'll stay incomplete, and that's it. You get one shot at corrections.
Okay, got it.
Yeah. This is not English class. No first draft, second draft, third draft, 18th draft. No, thank you. All right. Any other questions, everybody? Someday I'll have everyone show up. That would be great. 38's not too bad. What I want to do is I want to show you, I'm going to show you that video because it's relatively short. I told you about the video about complex numbers yesterday. I'm just going to go ahead and show it to you. So it's only like, it's not even 6 minutes long. I am going to have to do this. Hopefully people are still out there. I don't know if you all went to the other room, but when he picked up the picture, when he picked up the graph to show you the other dimension, both axes, the x and the y-axis, both have lateral axes of imaginary numbers on them. So normally when you see graphs of imaginary valued functions, they have to use color as another dimension. So if you ever look at fractals, and many of those are graphs of solutions to complex valued equations, you're going to see a lot of colors, and the darker the color normally is the more complex the answers are in that area. Has anyone ever seen that before? Fractal images that are all kinds of colors. I mean, I should have looked them up before, but is anybody still with me? Yes, somebody said yes. Okay. So, I mean, that's just the first part of, I think it's like 10 parts or something insane. And it's just remarkably cool. So anyway, I wanted to throw that out there. I'll put the link up if anybody's curious. It's Welch Labs is the name of the, I could even do it right now, can't I? I'm still not used to everything related to doing everything online. Okay, so with that said, this should be it here. All right. Kapow. Shit, did I do the right thing? Yes, okay, thank God. That's always exciting. So there's a few things I want to finish up in the, oh, that's right. That's the other thing I wanted to show you. Let me show you one more thing here real quick. This is so weird because my brain is saying there might not be, I think there's at least one person there because somebody just said yes. Let me show you this I just put up here. Right here. So I put factoring methods up there yesterday. And now I just put quadratic equations up here. And this is really just for you as a extra review kind of thing. But it goes over completing the square. Does anybody remember completing the square?
Yeah.
Yes? Okay. And of course, that's an explanation of where quadratic formula comes from. And then it goes over all the different ways to solve quadratic equations, which kind of goes into somebody's earlier questions. These are all the ways you could solve a quadratic equation. All right, so that's up there for you. It's nothing we're going to do specifically. It's just a review thing. But if you do want to try out some of the examples I give, you can always ask me if they look right, if you want a little extra practice. But that's, I think those are in the chapter 2 review exercises. Stuff related to quadratic. Yeah, there they are, section 2.5. The other thing I wanted to talk about, there are 2 other things I wanted to talk about, and then hopefully some more people will have some questions. There were absolute value equations and inequalities and rational equations, right? I don't think the rational equation should be a big deal for us, probably. Let me see. All right, cool. So I'm talking about stuff like, here we go. My markers are all dying. That sucks. Something like this. Yeah. Right. There's a problem like this in the review exercises that you have to do for homework. But what do I do with this?
Into 2 separate equations?
Yes, cool. And the reason that is, real quick, little side note. Can somebody tell me what this is?
An absolute value?
Well, true, but what's the answer to that?
Positive or minus x?
The distance to 0.
Okay, that's the idea of an absolute value. What's the answer to this? It's kind of a trick question. The answer is not plus or minus x necessarily, because that makes it sound like both of those are answers. There's only one answer, but it depends on what x is. If x is positive, what will the absolute value do to it?
Nothing.
Nothing. So absolute value of x equals x if x is greater than 0. What does it do if x is less than 0? Or greater than equal to up here. But what's it do if x is negative? What will the
Multiply by -1.
Yeah, it makes it positive, which means, what algebraically, how do I do that to a negative number? I multiply it by negative. Now, I really want you, the person that said plus or minus x, to understand why that's not the right answer. It is only one thing based on which situation it's in, right?
Yeah.
Okay, good. I like it. So that's why I can do this. What's the absolute value of what is 11? Well, the inside could be 11, or the inside could be negative 11, and of course it would come out to be 11. So that's right. That's why you make 2 separate. So this should be old news for most of you guys, but again, there's a wide variety of people in this class. So if this isn't old news for you and you want another example or you have a question, go ahead and ask. Now you just solve those and you're good to go, right? So here you get x is 3, here you get x is -8. You can check them and all kind of stuff. I did it quick, so hopefully my brain is working well enough. Okay. You guys all right out there?
Yeah.
Yeah? Okay.
Yes.
So, let me ask you this then. What would you do here? Let's see, what do you got, Jeff?
Would you subtract 4 and divide by -1?
Yes, so you must isolate the absolute value in this case. So you almost always the first step of any equation is to try to isolate where x is stuck, because then you can focus on undoing that stuckness of the x as I make up words. So subtract 4 and then divide by -1. Do it later, Jeff. So then you get 7 absolute value equals 6. And now it's the same as before. Is everybody with me? Is that all right?
Yeah.
All right. Okay, thank you. So what about, I saw some issues with absolute value inequalities in some of the homework I've graded. I didn't finish this, by the way, but it's exactly the same as the problem we just did. So unless somebody yells at me to finish this, I'm not going to. Okay. So how would I do this here problem? What do you got, Jeff? Do it.
You treat it the same as an equal sign?
No.
Flip the sign when you make it two equations.
Yes, sort of. So what I always think, whenever I see an absolute value with a less than, or less than or equal to, I think of a haunted house. I want you to stay close to me. What is absolute value based on? Why is it always positive? Because it's based on the, I think somebody said this earlier.
It's the distance from 0.
Distance. So I want the distance to be less than or equal to 11. So I want to be close. I don't want to get more than 11 away. So my answer should end up looking like this. Let me see. Brian, you got the right idea. So I think what you're saying is either if this is by itself is already less than or equal to 11, that's valid. And what else could happen to make this work? 3 plus 2x could be what?
Less than or equal to negative 11.
Greater than or equal to negative 11. Right? Is that all right? Think about it. Think about it. If 3 plus 2x was less than or equal to negative 11, so let's say it's, I'm sorry, less than negative 11. So say it's negative 12. What's the absolute value of negative 12? 12. Is 12 less than or equal to 11? No. So I can't let the number part of it get to be beyond 11. Right? So what's a better way to write this? I don't like writing it like this. It's way too much shit. Why don't I just write it like this? Negative 11 less than or equal to 3 plus 2x less than or equal to 11. You guys with me?
Yes.
Yeah.
So when it's a less than, that's the only time you're allowed to do this because of the fact that I know it's going to look like this. Stay close to me. right? Because it's a distance that's smaller than something. And then you just, I don't even want to, what is this going to be? Who cares about this, right? All right. You guys can all solve that, hopefully. And hopefully I did that right and did it quick. And then you remember interval notation, and then you can graph it, and blah, 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 blah. All right. So I call this a sandwich problem, because you got the bread and the jelly, or not. You don't have to. All right, so this might be an extreme review for some people, but please slow me down if this is from a long time ago. Just let me know if you need some help. So what would I do if this would have been a greater than?
If it has two separate equations?
Yeah, so if I have, let's just make something quick and easy here. So then it could be x plus 3 could be bigger than 5, or x plus 3 could be less than negative 5. Become a 5. What is that? So I've seen something kind of silly. If it's less than, well, less than, and this is great, or I'm not the biggest fan of those kind of things, but I don't know. I don't know if anybody's ever seen that to kind of help you remember when it's going to be an or, when it's going to be an and. All right. Well, would be facing. Oh, yeah. So you definitely, now watch. If you try to write this in one line, this makes no sense. Why does this make zero? Never write this shit for me, because I will immediately go, do you understand numbers? Why does that make no sense? Isn't that what it said?
Negative 5 can't be greater than 5.
Yeah, holy shit. Negative 5, bigger than something that is bigger than 5. That is news. And that's impossible. So never write that. That doesn't make any sense. Okay. I like it. All right. Any questions on that? Are you guys all right? Okay, all right. And then the other thing I wanted to talk about was something like this. This should be exciting because I just made this up, so you never know what's going to happen. I'll tell you what, go ahead and try to solve that. What is going on down there? Oh, okay, that's what I thought you were going to try to make with those little eyeballs. Just to make sure everybody's got the right first step. What's the first step on this?
Factor the denominator?
Yeah. So factor this so you see what you're working with. You can do it, Jeff. You really can. You made the problem, dude. I know. And there's kind of multiple ways to do this. When I teach this, I kind of teach it in the give it what it's missing idea. So what is this guy missing? He's missing an x plus 2. What is this guy missing? He's missing an x minus 3. He ain't missing shit. And then you can multiply both sides by that bottom, since there are both sides. If you multiply everything by x plus 2, x minus 3, the bottoms disappear, which is basically how you take care of any fractions in an equation. Okay, I don't want to be going too fast, but I also realize this is a review. But please tell me if Don't let me steamroll you, basically, is what I'm trying to say. Is everybody all right with this? You could do where you just multiply by the LCD directly. That's up to you. I don't care. Either way. So here I get 4x plus 8 plus 5x minus 15. I think that's right. Is that right? 9, 8, 7, yeah. So then you get x equals 7/3. Is that all right, guys? Have I bored the hell out of you, or have I lost everybody? Or is it something in the middle? Let's see.
It is hot as hell, but this class is very intriguing. I'm getting all my stuff done. 10 out of 10 in the rate.
I'm sorry, do it one more time.
I said this is 100%. You're doing the best job. 10 out of 10. It's just hot. And that's it.
I'm sorry, buddy. I'm so happy I finally have trustworthy AC. So I'm sorry if you don't. I used to be in a place where I had to put buckets of ice in front of the fan and just pretend like that did something.
No, I just have to go in a quieter place. So
oh, I see. I know. These are not optimal conditions. Everybody else all right with that? I mean, I don't want to go too fast or too slow. All right. All right, something's teasing me in the back of my head. So that one sheet I put up online about quadratic equations, you can review that. Completing the square will come back every now and again. It's useful. Some people think it's only there until we learn quadratic formula, but it is a necessary thing that actually has other applications. Okay, I want to take a real quick second and make sure I don't forget anything I wanted to say before I get into chapter 3. All right, good. Oh yeah, no, all right. I feel like there's something else I wanted to say, but I just can't remember what it was. All right. All right, I'll deal with it. I don't think there were any radical equations. That's what I'm kind of looking for. I don't think there were, or were they back here? Oh, well, I don't see them here either. Okay, so somebody, let me do this. This is going to become a useful skill very soon. Everybody's aware, just to make sure, I didn't really give, all right, so you have to excuse me. I feel very out of my element with starting the semester online. I've never done that before. But this course, you could have taken 170 and 175 separately, right? I don't even know if you guys, if everybody understood you could have done that. 176, it shaves a unit off because we're able to be more efficient with going through things. So what we're going to do is we take what's called college algebra, and we also put trigonometry in the middle. So I don't know, if you've never done any trigonometry, that's basically what I'm going to assume when we get to it. Has anyone ever done any trigonometry before? I think somebody is taking a break. Oh, somebody's clapping. I like that. Yes. Yes. I like it. Sweet. So when we get there, it's not going to be over 12 years ago. Okay. We'll see how much surface is and how much you just have to start over. Okay. So let me do this. What was it I wanted to do? I'm trying to make up for the fact I was hoping there would be, I don't know if not everybody's definitely gotten into chapter 2 review, and not everybody's even gotten into chapter 1 review yet. You guys have got to get in there so you know what to ask. Let me see. All right, I can't remember what it was I was going to look at, so I'm just going to jump right into this because this should come up. So this is something that's going to come up when we get into trigonometry, especially. What would you do with this? It shouldn't be that big of a deal because we've actually done harder problems.
Multiply the numerator and the denominator by the root. So you put the root on top?
Yeah, exactly. So, and do you remember what this is called, this process? It's all right if you don't. It's called rationalizing the denominator. Because the denominator is now a rational number, whereas before it was irrational, right? So we did a harder problem that actually had a couple of, we did actually one with a complex number in it. Same basic idea, right? So why is this preferred over this? Because the radical, at least, is not in the denominator. It's a real, what do you call it? A rational coefficient of an irrational number. I don't have an irrational denominator, which is like 2 layers of bad. But to be honest, if I said, there's going to be reasons to do this later also. If I said rationalize the numerator, let me see if I can give you one that's interesting. You can do it. Can you do it, Jeff? Can you do it like real fast? Sure. Let's see. Can you, Jeff? Oh, I don't know, man. Yeah, I want to make it, that's true. Give me a second. Yeah, that's true. Okay, that'll work. This looks like it's going to be exciting, Jeff. Yeah, that'll work. Does everybody understand what I'm asking you to do? Because right now I'm just sitting down waiting for you to do it. Go ahead and rationalize the numerator. This is so ultimately weird because I have no way to knowing anyone's actually doing it. All right, so just to help everybody along, if you guys remember, we did one the other day that was like 3 over 7 plus I. What did we multiply by to rationalize the denominator?
Was it 7 minus y? Or I?
Yeah, I got you. And that's the conjugate, right? Same idea. So you multiply by the square root of x minus 2 plus 3, top and bottom. I'll wait. Something very interesting should happen. I gave myself no room for this. Here's a big hint. Don't multiply the bottoms out. So I'm going to go this way with it just because I have a little more room here. What do you guys get? I get, what's rad x minus 2 times rad x minus 2?
X minus 2.
Yeah, you got to love that shit. Half of this times half of this is a whole of this. All they found each other. So I make a whole one of these. And then this and this cancel by design, right? And then I get minus 9, which is x minus 11 over x minus 11 times crap. These cancel, so I get 1 over, where are you? Go away. 1 over crap.
Can you explain that one more time? You lost me.
All right, so you're cool with the first step, right? That's the conjugate. multiply top and bottom by the conjugate. Then I just FOILed, right? Rad this times rad this makes a whole x minus 2. Right? Is that all right? All right, cool. And then the middle terms cancel by design.
Okay.
And then negative 3 times 3 is negative 9, which makes this x minus 11.
Oh, okay, got that.
And that cancels, and so you have 1 over that.
Why is it plus 3 and not minus 3?
Because it gets multiplied by the conjugate, yeah.
Oh, okay, got it.
I like it. So watch, real quick. Just this might be really foreign to you because you're like, well, it does look better than this, doesn't it? There's less going on here, but we're used to not wanting a radical on the bottom, right? Can you evaluate this at 11? What happens if you try to plug 11 into the original problem?
Your denominator is 0.
Even worse, to be honest. What's the top become? I mean, you're right. The denominator is 0 when you put an 11 in. But what's the top become when you put 11 in?
0.
So, does anyone understand? 1 over 0 is undefined. 0 over 0 is worse. 0 divided by anything is 0. Anything divided by 0 is infinite or undefined. So what is 0 divided by 0? It could be anything, says Mr. Hand. It could be anything. But now we know. What do I get when I put 11 here? One over 6. We can actually do it. Do you understand what I'm saying? You understand what I'm saying? No? All right. Well, shit. All right. If any of you, how many guys? I got one yes. Okay, thank you.
I thought you were gonna have a square root.
2 yeses. I love it. Sorry, say again.
You can leave the square root in the denominator.
So there are. Do you see? I try to be very specific about pointing out that I could not evaluate the original expression at 11. By doing this, I can now evaluate it at 11. That might not be like amazing or anything, but if I needed to know what it was at 11, I have to know to do this, so now I can evaluate it at 11. Does that make any sense? I think some of you guys said it did a bit, but even if it doesn't make sense, it's okay. I'm getting a little ahead of myself, but the idea of conjugate goes beyond pre-calculus. So we use basic ideas in higher mathematics for different reasons than we would have ever thought before. So this is just in your future. Did it change the value of x? No. No. And I don't know if anyone, this is related to the idea of limits, which is something we'll kind of introduce in this class. And then if anybody has to take calculus, does anybody have to take calculus after this? Let me see how many people are with me right now. Can everybody answer that question? Does everybody know where yes and no are? This will make me feel so much better if 38 people answer that question right now, so that I know that nobody logged in and then went to bed. So don't answer in the chat, answer in the yes, no. If you hit participants at the bottom, you should be able to answer yes or no, right? Here we go. Here we go. We're getting somewhere. Somebody's giving me a thumbs up. I like it. So I'll add that in. I'm up to 30 now. That's all I can do. Okay, so 8 people are AWOL. Okay, or just don't. Maybe on your phone it's weird. Oh, there you go, 7 people. All right, that's enough of that. Okay. So, let me see. Did I? Yeah. Okay. So for the moment, I'm going to leave chapter 1 and chapter 2 behind. since there's no questions. I try to leave some room for taking questions.
I have a question for chapter 2.
Yes, please.
Can you go over question number 22?
All right, let me see. Oh, beautiful, 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 beautiful. I like it. What did you try to do? And by the way, let me share this so everybody can see this in case you don't have your book like right there. And I'm not putting you on the spot. If you're really just not sure from the beginning, just say so. But did you try to do something?
Yeah, I plugged it into the formula m equals y2 minus y1 over x2 minus x1.
Okay.
And I ended up getting like m equals 6 over 0. And I didn't really know what to do after that because I didn't know how I would plug that into the point slope formula.
What kind of line has a 0 slope, for example?
A vertical line.
Well, no.
Wouldn't that just be a horizontal line?
Horizontal line. So that matches with reality, right? If I said there's no slope to this floor, like then it would be a flat horizontal floor. Are you with me? So the idea of slope is definitely an idea in math that perfectly matches the idea in the real world, like grade on a road, right? So what kind of line would have an infinite slope or undefined slope?
Vertical.
Vertical, the one that's perpendicular to 0 slope, right? So vertical line. That doesn't really, now you're sitting there going, okay, that's great. How do I use the formula? Well, can you look at those 2 points and just tell me what the relationship is between them? That's all an equation is. That's all a linear function is. It's just a relationship between points.
It's just x equals 5.
Yeah, that's it. That's the equation. And what kind of an equation does a vertical line have? An x equals equation. Because if it only goes up and down, x isn't changing. X is a constant. What's y? Anything. That's why y wouldn't show up, because y could be whatever the shit it wants to be. Does that make sense? I will agree with you. That's really weird if you try to treat it like it's a normal situation. But it is one of the 2 extreme situations, right? You can have lines and they can match up with mx plus b beautifully. And then this guy goes, I got problems. And this guy goes, I got some problems too, right? Those are the 2, I can't make it. Those are the 2 extreme situations. Does that help?
Yes.
I mean, we basically gave the answer. So I guess it does help, but as long as it makes sense too. All right.
Can you also go over 28?
28. Oh, okay. Thank you for this. This was something else I wanted to say. I mentioned this really briefly yesterday, and it sort of came up a little bit today. But if somebody wasn't here yesterday, if you forgot, and you saw the video today when he picks up the graph, right? Am I sharing still? All right, let me stop that. There we go. When he picks up the graph and it gets all colorful, what's happening there is next to the x-axis, so this is the real number line, there's also the imaginary axis, right? And this is the whole thing we talked about where the rotations come into play. So when I give me, so for example, if I had -5 plus 7i, what's you can do it, Jeff. The horizontal component would be the real part, -5, and the vertical component would be the imaginary coefficient, 7. Does that make sense?
Yeah.
So if I were to rotate this, so let me do it like this. So if I have a number line here, the real number line, you can do it, Jeff, and I have the imaginary number line coming out, that's what he was doing when he was lifting that graph. He was showing what it looks like as you step away and get into the imaginary parts of it. And that kicks excessive amounts of ass. And I wish we taught that earlier in math. For some reason, it's looked at as, it's only difficult now because we didn't talk about it before. So I do wish we taught that earlier.
Lateral, not imaginary.
Thank you. You got to help me with that movement to, I say imaginary just because I know that's what everybody knows, but we do need to start changing that to lateral. I don't know. It's going to be the same time that America decides to start using metric is when we'll start calling it lateral, but oh well. I
I have a question.
Yes.
Did we go over number 56 for chapter 1 yesterday?
I have no idea. Let's take a look. Oh, we sort of did. I don't know if we did that specific one, but that's the cubes one, right? The 8x cubed, that one?
Yeah. I was having trouble with that one.
So let's do this one more time. Okay. I've got to figure out a better format for my little studio here. So really, if I have something cubed plus something else cubed, somebody's laughing big time because I referred to this as my studio. I'm gonna become a YouTube influencer or something. I don't know. I don't even know if I use that word right. This is definitely not this. It just so desperately isn't, right? Because are you allowed to just distribute a power across addition? I mean, I'm sort of giving the answer in my tone. Of course not. Now, what would you do here? What's different about this? Can you do something there?
Yeah, you can distribute it.
Because exponents are based on multiplication. So, of course, they're going to play well with multiplication. Here, exponents are not based on addition. They're not going to play well. This would have a whole bunch of other freaking terms. So what I do, what ends up happening is I have to break it down 1, 1, 2, 2. So I put 1A here, the other 2A's there, 1B here, the other 2B's there. Same sign, always positive. Who remembers what the middle term is going to be?
The wolf.
AB.
Say it again.
AB.
Yeah, AB. And
like a reverse
negative.
Like negative, right?
Whoa. So it can do its job, right? So it can kill the parts that we don't want. So how does it apply to your problem? So if I had something like 27w cubed minus 125. Little dude, big dude. 27w cubed. So what am I going to put one of here? What's this made of? It's
3w.
3w. So 3w times 3w goes here. That's the other two. So overall, there's my 27w cubed. What's going to go here? One of these. What's one of these? What is this?
5.
3 5s. Same sign. So the other 2 5s, 5 times 5, 25 is there, always positive. So there's my minus 125. And then if you missed this the first time I said it, I also get minus 45w squared. I also get plus 75w. I don't want that shit. So the middle term has to be the opposite sign. And what ends up working is this times this. That will kill the 75w and it will kill the 45w squared is hopefully what the other one, yes. Good. That might have been too fast. You didn't see that before, but is that all right?
Yeah, I think so.
Okay. All right. By the way, guys, I am going to let us out a little early. In general, if I'm going to keep us the whole time, I will give us a break. So if I forget, just say, hey, are you letting us early or should we get a break? And I'll go, oh, shit, let's take a break. Oh, here's another question. 66, chapter 1. Oh, dude, yes. So a lot of people were doing this and not showing me enough work. Wait, am I in the right place? Chapter 1, yes. So that's the one with the 4d squared minus 7d. That one, Joshua? It looks like it probably is. Yes, okay. So let me just take one piece of that. So it's got 4d squared minus 7d minus 2. And it's got other shit. It's got something here times something there, over there. So I need to see the work that goes into factoring this. So you could actually do one, you could take one piece, do it, take another piece, do it, take another piece, do it. One thing I want to tell you, so if you multiply those, and I see this a lot, I mean, let me see, somebody can maybe remind me how this, so -8 and -7, right? And then it'll be things that add to be -7 multiplied by -8, so it'll be -8 and 1. Let me write that in a different color for myself. What I really, really don't like, unless you can explain to me why it works, where'd it go? -8 and 1, is when people divide by 4. It'll get you the right answer, but do you understand why? People, I don't know if those yeses are from earlier. Would anybody be able to explain to me why that method works? If you can't explain to me why it works, never use it. If you use it, I will tell you, you get no credit until you explain to me how this works. And by explaining to me how it works, I mean, we'll have a Zoom session one-on-one and you explain it to me as I look at you. You don't pay somebody on check to make it something up for you, no. All right, I'm sorry. I don't mean to be so evil right now, but the reason I hate that method, it's because the hardest part of the problem is done. And then magic happens. Why? I don't need the magic. Because I know these numbers and that I just rewrite this. Using the 1 and the -8. And then I group. Who gives a shit? I don't need any help anymore. What's funny to me is the part that people can't explain happens after what is normally the hardest part of the problem. I don't know if anybody is with me or if anybody gives a shit. Everybody should give a shit because if you do this, I'm not going to count it for credit. So if you do the weird magic shit, but this is beautiful. Ain't a damn thing wrong with this. You can do it, Jeff. There you go, buddy. All right, and then why did I do this whole problem for you? I don't know. I just couldn't stop. All right.
Because you have 3 others, you have to do the same thing.
Oh, that's true. Thank you. So I did 1/4 of that problem for you. I'm glad you reminded me. And now I'll do the other 3 parts of that. And it is divided by also, so don't forget to flip the other dude. By the way, let me ask you this. Maybe I'll do 2 things and we won't get, I wasn't really planning on getting into chapter 3 tonight anyway. I want to do 2 things that are very basic unless anybody has another question. But the 2 things we're going to talk about are 2 things that people often don't even get to see or get to have explained. But Joshua, does that answer your question? That your question might have been sort of, what work do I have to show maybe or something like that? Joshua? Yes. So you're good? Okay. Let me ask you a really basic question. Does anybody know why we do what we do here? I didn't show you this already. I think I showed it to my morning class, but I don't think I've shown it to you guys. Does anybody, what do I do here, of course, to do this problem?
You would multiply by the inverse?
Yes, I love it. Multiply by the reciprocal. Kick ass. Does anybody know why we do that? Has anyone ever been shown why we do that? Would anyone like to know why we do that? I like that. Somebody marked, please don't tell me. Don't ruin my life. You're about to ruin my life, Jeff. I know it. All right. So let me, all right. I'm about to show you why this works. I'm about to do this in a remarkably weird way. Never do this the way I'm about to do it because what I'm doing is explaining why the way we do it works. Is everybody with me? I always get somebody eventually go, why is the guy making it so hard? What's his problem? Okay, all right. So here's what you would never do. Right? Nobody wants to do that. Right? All right, I love it. And you're all like, dude, you're the one taking us here. I know. What sucks about this? Because the bottom is probably one of the worst denominators you could have. What is the best denominator you could have? What am I drinking? Denominator, officer. It's tasty. What is the best number on the bottom you could have?
1.
1.
Yes, I love it. What would I multiply this by to make it 1?
15/8.
15/8.
So then I have to do the same thing to the top and explained. All right. Okay. Is that cool? I mean, it's relatively simple if you get past the first step. Multiply by the reciprocal so that you get a 1 on the bottom. You got to do the same thing to the top. So this becomes this. That's the shortcut now. I like it. Was that just boring or was that all right? I don't know. It almost doesn't matter. We all know what to do. The other thing I want to ask you is, can anybody tell me if this number, without doing any work, can you tell me that's divisible by 4? Does anyone know how to tell without doing any work? Or like minimal, like nothing? This is what I'm always, sorry, go ahead.
I would say yes, because 24 is divisible by 4, or 4 is divisible by 4.
And so what was the last thing you said?
Or 4 is divisible by 4. It's the last number.
Oh, no, doesn't work. Sorry.
Okay.
Thanks for playing. But the 2 last numbers is what matters. If the 2 last digits in any number are divisible by 4, the whole damn thing is. And if you think about it, 4 goes into 100. Therefore, 4 goes into 124. Therefore, 4 goes into anything 100 and multiple of 4. I don't know if I put that together grammatically well enough for anybody. Do you guys understand that? Has anybody ever, now, like for example, do you guys know the rule for 9? How do you tell if something is divisible by 9? This used to be the one that everybody certainly knew. What's 9 times, I'm sorry, go ahead.
Wasn't it like if the 2 last digits add up to 9?
Add up to, no, not the last 2 digits.
All the digits.
All the digits.
To a multiple of 9. Then it's divisible by 9. Which is a really neat thing. And you can see it in action. What's 9 times 5?
45.
4 plus 5 is 9. I mean, so you can start to see it happen. You can see it all the way through. So for example, this number here, what do you got, Jeff? That number there is that divisible by, wait, let me save it. What did you do, Jeff? Oh, I see what you did, you silly person. There, is that divisible by 9?
Yes.
Yes, because it adds up to 27, so it's divisible by 9. It's also divisible by 3 because the rule is the same for 3, which kind of makes sense because 3 goes into 9. Any number where the digits add up to a multiple of 3 goes into it. Is everybody with me? Has anybody heard those rules before?
Yes.
Some of you guys, okay. But some of you guys have never, does anyone think they've never heard those kind of things before? A few of you guys?
I've never heard this.
All right. So I always am open to the possibility that maybe you learned it such a long time ago you forgot, but it actually, I have verified that there are people that have never been shown this before. And to me, if I were you, I would be pissed off a little bit. I'm like, I should have known this. Let me see what's on. I don't want to keep us too long. Let me show you. The only thing that doesn't have a rule is 7, by the way. There is no rule for 7. 2 is even numbers. 3 we talked about. Add 2 multiple of 3. 4 we talked about. 5 you know. 6 is interesting. What do you think about 6? 6 is 2 times 3. So what must be true about the number? the digits must add to be a multiple of 3, and it must be an even number. Isn't that interesting? Does that make sense?
Yeah, that makes sense.
So if it adds to be a multiple of 3, 3 goes in. If it's even, 2 goes in. Therefore, 6 would go in if both of those are true. I like it. All right, maybe that's where I'll stop. I know that's a very, very basic arithmetic kind of thing, but I don't care what level of math I'm teaching. I like to check to see if people ever saw that. And yeah, you're right, Amber. You should be a little pissed. It's kind of like all the education has moved over to calculators. We have calculators. What do I have to know shit for? Because we made numbers up. We're humans. Tell me about the shit we made up, please. Right? All right, sorry. I'm on a little crusade with that, but I think that's enough. Where are we at? Yeah, I promised I'd let us out a little early, and that was a promise to me too. So I like to keep those kind of promises. So there was something I was going to do. I got to remember. I got to figure out how the quiz is going to work, and there's something else. For tomorrow's class, I'm going to try to, I have no idea if you like this or not, and it doesn't matter because we're going to do it anyway. I'm going to try to have some more stuff that you guys work together in groups because I do want you to get to know each other. And I think I've told you this before. I hate that you guys can't get to know each other as easily as you could have before because that's a huge part of being in college. So I'm going to try to do more group work stuff. Once we're out of the review sections, it should be easier to do that. We'll have very focused things to work on. Otherwise, I'm going to go ahead and end the class. You can leave if you want. If anybody has questions, please ask them now.
Thank you.
You're welcome. So you can head out if you don't have any questions. Drop your Insta. What the shit?
I actually have one more question. I'm sorry.
Oh, yes, who's this?
Athena. Can you do
Oh, there you are. Okay.
32 on Unit 2 or Chapter 2?
Let's see, 32. Oh, okay. The interesting thing about that one is there will be like terms. It won't. Will there? No. That was just a neat one. Just do as much as you can. So like the square root of 25 is obvious, right? I am looking at the right one. It's the 2 rad negative 75 plus 3 rad 25, right?
Yes, yes.
All right. So the 3 rad 25 is easy. The rad negative 75. What can you do with rad negative 1? That, of course, is what?
I.
So then you just have to work with rad 75, and you can break that up, right?
Oh, okay, I understand.
Yeah. So then it's just it's going to become an A plus BI. It's going to become a complex number in the right format.
Okay, thank you.
Sweet. All right. Anybody else? Let's see. Understand 70 on Unit 1. Oh, yeah. Okay. We did do an example like that one. So, Christina, if you can combine the fractions on the top, then you just multiply by the reciprocal on the bottom and then cancel what you can. Does that make sense? So on the top, you just need like denominators so you can see which one is missing what. Okay, okay. How's everybody else? Who actually is out there right now? Who is in the other room?
I am. I actually had a question. Do we need to use graph paper? Because there's a problem in section 2.
I would highly recommend all your work on graph paper. I got to a point, well, to be honest, I got to a point and I started doing all my work in graph paper, and then I got to a point above that where I started doing all my work on just blank, no lines, no nothing paper. So it's a weird progression as you go up higher in math. But this is the class where you almost want to just do everything on graph paper because you never know where you're going to have to make a little graph for a problem. There's going to be a ton of graphing. Yay! So
I kind of figured that.
Might as well order some graph paper off Amazon or something.
Okay, I'll do that then.
All right. Anybody else out there? Or am I
Yeah, I have a question actually about earlier in like chapter 1, there were some questions about finding like the principal square root.
Yes.
I was just wondering, like for one of them, it was question 30 from the chapter 1 review, where it was like find the principal square root, but really like all it was, I think, was just simplifying it. Like
that's like a typo is what I would identify that as. I when somebody was asking about the last problem with the cube root, I should have said something right then, and then I forgot to. But I think they mean that to go through 29. And then starting at 30, they should have just said simplify. Because the instructions find the principal square root stop making sense at 29. Right?
Yeah, I was just kind of confused with that whole section, because then it was like find the square root of 121. I wasn't sure if it was just like the square root of 121, or it was like...
So for 22 through 29, they say find the principal square root. They could say find the principal square root represented or something. So it's already a root. They want you to find so when I say find the principal square root, it's the positive root, right? I don't know if that makes sense. So it didn't mean introduce a new square root. It meant for the square roots below, find the principal square root.
Okay, got it. Yeah, that whole section was just kind of weird.
Number 30, they should have just said simplify after 30. Yeah.
Okay, got it. Yeah, thanks.
Sure. All right, who else
I
is...
have a question in terms of the book.
Yes.
Well, for chapter 2, I'm not sure if I'm on the right, if I'd be doing the right equations, because someone asked a question like, oh, what was the answer 36, or help me out 36 or something like that. And I wasn't sure if I was on the right one, because I'd go for these questions. I went to 2.1 in the textbook, and then I just did the ones that were all the way at the bottom. Am I doing that correctly? Am I actually doing the questions or no?
No, let me see how I put it on the homework sheet. I should have put a page number in there, did I?
For chapters 1 and 2, you didn't. That's why I was like, wait, what?
It's the review from, I didn't, I'm sorry. Yeah. And sometimes I'll do that because with these open source books, the page numbers are different if you have a physical copy or the online copy, which is funny. But it's the review. How are you accessing the book? Are you viewing it online?
I'm viewing it online, yes.
So when you go to chapter 2, you just go down to review exercises.
Review exercises?
Yep, and that's where the assignment's from.
Review exercises. I see,
Here, let me show you.
Yeah.
So here I am in the book, right?
Mm-hmm.
And if I go down to chapter 2, go down to review exercises.
Or practice tests.
Right above practice tests, it should say review exercises, right?
Because I was only doing 2.1, so when people started asking questions about specific numbers, I was on the wrong one.
I got you.
Okay.
Yeah, I like this book because chapter 1, chapter 2 are basically, like I said, they're all reviews. That's why I just did the review exercises. And you can always go back to these sections if you need more explanation or, of course, ask me. Right.
Okay. Then I've been doing exactly the wrong thing.
I'm sorry. At least you found out now and not like a week from now.
All right. That was the only question I had because...
Okay.
Can we directly message you
sorry.
or email you if we have any specific questions? Because during class, I kind of get like shy because I understand people are more advanced than others.
Oh, please, please, please. I'm not going to make you ask. I understand, but you have got to understand if you have a question, at least 8 other people have that same question, and you could be a hero for them. If just for one day, you could be their hero if you ask a question. But I'm not forcing you to ask questions. You could stay after class like you are right now. You can email me, whatever.
Okay, thank you.
How about, is everybody else an actual person that's here? If nobody has a question,
I have a question for I was trying to correct the homework I did for chapter 1. Yes. And in one of them you circle, because I do the star method for factoring, and you circled one of them and you put question marks, but you only did it to one of them. So
I might have just been like, all right, this method is not good. Is it one where you divide and the magic happens and you know what numbers to put? Is that what you mean?
It's a variation of that because the one you said was different than the one I used. Like you were saying that then you divide by 4, but you draw the X for me and then you have the line in the middle. So the ones that are above the line are how do I explain this without like?
No. So, but do you, what was that problem we had earlier? I can't remember. Let me just make one up. This is one that I know works. So negative 24, do you do this, right?
Yeah, except there's like another line right across the middle.
And then
on the top one, yeah.
3, and up here you would put 4.
Yeah.
Right, that's exactly what I don't want you to do.
Okay.
Unless, can you explain to me why that works?
You got me stumped there.
Okay, I'm sorry. I'm not trying to be a jackass. I hope you understand.
I understand.
I had one student come to my office, sit with me, and explain to me why it works, and I was like, "Holy shit, you can use it." But that is the hardest part of the problem.
Right.
And then you just break up the middle term and do grouping. Man, I need a haircut like crazy. I try to cut my own hair. Anyway, don't do that, kids. But that's what always gets me is the next step. If you do that, you don't even know why it works. And that should frustrate you. And then you realize, I don't even have to do that magic shit. I could just do grouping and be done with it almost as fast. Okay.
That was it. Yeah, it was it. Thank you.
Amber, what's up?
Hi, I have a question, but it's on chapter 3.
Yes.
Okay. Yeah, I wasn't sure if I could ask it or not because you haven't actually covered it yet.
Yeah,
but,
well, we're not in class anymore now. So,
so on number 33.
3-1?
No, 33, 3-1.
Okay.
Yes, sorry, 3.1, number 33. There we go.
Gotcha. Okay.
I'm trying to figure out, because it wants me, so I get the g of x, you just input that equation, but I can't figure out the g of a. What is that?
Ready? Tell me this. You ready? Just answer this. What is g of x?
The x squared plus 2x?
Beautiful. G of x is x squared plus 2x. So what's g of a?
Not that.
Come on, you can do it. If g of x is x squared plus 2x, what's g of a? A squared plus.
Oh.
Yeah.
Okay.
So I know it's kind of weird, but function notation is just substitution. So
yeah. Okay.
even letters just get substituted. Yeah. And something really cool should happen on that one. It's kind of related to that radical problem I did earlier where we multiplied the top by blah, blah, blah.
Yeah.
That kind of feeds into this. This one's a little bit easier, though. It's no radicals.
Okay. Yeah, because I was really confused because I was like, I don't know what that is. I don't know if it was a different equation or what.
Yeah, just think of it like x was a random letter. The history of why we use x is interesting, but we could have really used any letter to be like the standard variable. So we could have used a. Why not? And it would have been a squared plus 2a. And that's exactly what g of a is.
Okay. This makes sense now. Now I can actually do it. Okay. That was it.
Okay. Dalton, Luke, and Areli? Did I say that right?
Yeah, you did. Areli.
Okay. Yeah. You guys all right? I mean, class is over, so I'm only going to stay if somebody has a question.
No, I was just trying to figure out how I could explain the star method to you.
Oh, okay. Good luck.
Okay.
You can probably imagine that I'm not going to help you.
Yeah, I figured.
But, I mean, you should have a little motivation, and it's not impossible. Obviously, it's not impossible to figure out why it works, but it's not immediately obvious for sure. So, I mean, if you get close, if you show me something like, I think I'm close, I might help you out with it. But I just don't see a purpose for it, to be really honest. Yeah.
I like using it because it seems almost like a shortcut, like a nice, like I can do my steps a little faster and I don't like muddle my work together.
And some shortcuts I'm okay with, but when the shortcut takes you away from the concept, that's where things get dangerous, especially if you're going to go further in math. Then you have a shakier foundation.
Oh, okay.
That's my own opinion, though. Some other people disagree with me, but oh well. Too bad for you. You got me. Luke and Dalton, are you actually there? No. So they went back to bed. All right, I'm going to close things up. I'll see I'll see you later.
Okay, thank you.